that I was just really excited to have a project.
Right.
And someone was letting me do a project that was related to something that they had just introduced to me that I got excited about. And like that was it for me. Like that was
That's all it takes.
that's all it takes. Yeah.
I
Like
think the reality is that nature is so fascinating that and all of these academic disciplines are so fascinating. To some degree, it doesn't really matter what you start doing. If you're sort of curious, if you're just someone who's really into science in general, and obviously there are certain projects that are going to appeal more to some people than to others, and the only way to discover that is to dive in and start doing them. But I think that really there are probably it's a bit like that kind of stereotype of the one true love, and I think that people get
yeah.
it in their head that there's this sort of one right research field for you. I think that just judging by my own experience and the experience of people I know like yourself, I doubt that that's true. I think we all have at least a couple of things that excite our curiosity. And,
At least a couple. Like there's some nice idea of like the romantic perspective of like this is the best field that I could have possibly gotten involved in for myself.
yeah,
Right? But there is no way, and it's almost sad in a sense that I'll never know this. There's no way for me to know that if I got involved in some other field that I wouldn't have felt the same or even more excited. Right?
I mean, absolutely. And I think that that really is just an invitation to try as many fields as you can and to experiment with as many different areas as you can and to try to find the one that excites you the most, because undoubtedly there are many, many things out there to find interesting about research. And now I find myself at the end of my PhD thinking about what I'm going to do next, and having the opportunity to consider other research topics that I might apply my skill set to. And so that's very, once you sort of emerge from the process of doing your PhD, whether you're going to stay in academia or not, you have this exciting breadth of options that you can apply your skill set to that often look very different from what you were doing before, but are no less exciting.
Yeah, that's true. Like your PhD and your master's is really a story. It's not just a story of getting used to your Yule says, glad this channel is about StatMech and not optics.
It's funny you say that, because if I could interject here with a sort of small anecdote, I did geometric optics in my second year and I hated it. I was completely uninterested. But in retrospect, my goodness, do I ever wish I had paid more attention to optics. I think optics is one of the most truly fascinating fields of physics research. You can do such incredible things with lasers. It really is like the perfect playground for quantum mechanics. And if I could go back and I could do it all, actually my undergraduate research project was in optics, and it was in atomic and optical physics. And if I went back and I did it again and I had to think about what field I was going to go into, atomic and optical physics probably would be high on the list. It's a totally fascinating field.
Yeah, I guess I share that sentiment a little bit, though. I don't know if this hurts my sort of physics street cred, but I actually never took a formal class in optics.
You're a mathematician in physics, guys. I think it says physics on the department website, right? But we all know you're a mathematician at heart.
Right there, you're digging into part of my imposter syndrome.
That's
but back to what we were talking in terms of like switching fields and stuff like that. So on one lens, or one way to look at your PhD is sort of you're slowly getting more and more used to your field and getting better at reading papers, maybe in adjacent fields and things like this. But really, you're also building up like a skill set that in a lot of cases will be applicable in many different fields, right? Like a lot of these techniques are very general. So I guess that is a nice spot to be at when you're about to graduate your PhD. You have all these skills you built up, and you could apply them elsewhere. In fact, a lot of very high impact results come from people switching fields and porting techniques in between fields.
Isn't that the truth? I mean, I think that there is something to be said if you sort of imagine like a sort of graph of all the results that cite each other. Results that bridge to clusters of citations are always nexi of research activity. If you can take a technique from one field and apply it elsewhere. Some of the most exciting activity in condensed matter physics came in the mid-20th century when people who were doing particle physics began to realize that you could use all of those particle physics techniques on condensed matter systems. And that's become one of the most fruitful branches of condensed matter research, is understanding critical points in understanding phase transitions in terms of these field theories, that all of the techniques are really ported, or at least at the beginning, all of the techniques were ported over from particle physics, and now it's happening with string theory.